Thank you, everybody, for coming today. Brent will be our first presenter this morning. Once he's done with the present, we'll take a quick break, have lunch, and then we'll have our second presenter, Chris Cox and Sam, come on. Scott Dwyer couldn't be with us today due to COVID, but we'll probably try and get him on another event. So thank you, everybody, for coming, and I'll get the mic over to Brent.
Well, good morning. Good to be here. I'm sure there's still people trying to figure out where we're at, right? And we're coming in. Couple of things first. As we are recording this, and I believe live streaming, is that right? If you have a question, you need to raise your hand so Jacqueline can bring you the mic so that we can get it out there for everybody to hear. We have recordings that people have asked questions and they kind of go on for a couple of minutes with their question, and for me to, repeat that question, it gets pretty difficult. And I think it's just a little bit cleaner if you have the microphone so everybody can hear when they're watching the presentation after. I'm going to ask a question, and we don't have to have the microphone because I can repeat it, but I want some response on where do you think we're at right now as far as energy code compliance in Utah. Are we doing a great job? Are we good on certain components? So in just 2 or 3 words, Jeff, I'm gonna call on you just to break the ice.
I'm guessing we're maybe 80% of stuff that's being built is pretty close to code.
So about 80% is close to code.
Multifamily, maybe less than that.
Multifamily, less.
Depending on where it's built. If it's in Salt Lake City, less.
Depends on where it's built.
Yeah.
So are you saying some jurisdictions?
Some jurisdictions enforce the code more effectively than others.
Some jurisdictions enforce the code more than others. So for me to get a feel for what we have here, Dan's an HVAC guy. Sam's a home designer. Got a builder over there. We got an HVAC guy there. We got a HERS rater here. We got a fire guy, right, Shane?
Yeah, I'm a general too. That's why I'm here.
General contractor, plans examiner, fire plans examiner. Is that what you do? Next to,
Manufacturer.
I'm sorry?
Manufacturer.
Manufacturer, great. Same, manufacturer. And in the far back? HVAC contractor. And we have several more coming. So, Ryan, you're an HVAC guy. You attend classes here, so you have a general understanding of the energy code and what it involves. In fact, you're using it every day in a load calculation. And you do work around in various parts, probably more north, is that right?
Yeah, Davis, Weber, Salt Lake, Tooele County, and Summit Ridge is where we're working now.
And are you seeing the same thing? Some jurisdictions are doing better than others?
Yeah, I would think you're probably closer to 60%.
60% in your experience. Yeah, and I think the numbers vary a little bit. For instance, Jeff, you're going to homes that know you're going to be coming to those homes, and so maybe they're at least trying a little bit to get there. We had a class yesterday with Rocky Mountain Gas Association, and I think Dan here mentioned that, or maybe it was Mitch, that even when people know that someone's going to come and test the house, it still doesn't do well all the time. And so I think we have some things that are being done right, and we have some things that are doing wrong. And so what I'm going to talk about first is a DOE study that we participated in, where we looked at a certain number of houses to see where they were at. And for those that are in the room here, I do have my little quick guide to the Utah Energy Code, Residential Energy Code. For those that are online, it's on our utahenergycode.com website, and I might refer to that a little bit as we go through. Of course, I need to mention that supporting all this, and I don't think anybody had to pay anything to come to this class, is Dominion Energy and the Rocky Mountain Power and the Utah Office of Energy Development support this training, and we thank them for their support. For those that aren't familiar with it, I work under a contract with them, and I'm available to help you with questions. So if you have a question or something, my contact information will be at the last slide. You're welcome to send me a text or an email, and I can try to answer your questions regarding the energy code. Okay, so we had this energy code field study. Now, this is the second one we did. About 6-7 years ago, DOE funded a 90% compliance study, and what they were trying to determine is what would it take for us to become 90% compliant. And so with that study, and I participated in that as I was at Salt Lake County as an inspector, we were asked to provide a certain number of homes that someone could come look at. Now, do you think we got a real good representation of homes in each of these jurisdictions? We had two problems with it. The first thing, it was completely voluntary. The jurisdictions had to agree, yeah, you can come look at some of our homes. So guess what jurisdiction said, yeah, you can come look at our homes? The ones that were enforcing the energy code. And as an inspector for Salt Lake County, I said, yeah, we can look at some homes. And so they said, okay, well, find us several homes that we can look at. And being human, guess what I did? I picked homes that I was comfortable with having someone else come look at it. So it probably wasn't the most accurate because we had the jurisdictions volunteering and then the jurisdictions deciding which homes we wanted to look at. And they came up with some number that we were like 80% compliant with the code. And this was 6-7 years ago. And I don't think that was a very good representation of where we were at. And so DOE in this more recent study, they asked that we do it a little bit different. So we're going to go over what we did, and then we're going to talk about the things that we're doing well on, things that we need to improve on, and we'll go from there. So those are the things we'll talk about, the project, the analysis, the data, and discuss the education and training phase. And in the end, one of the things that we want to do is focus on those areas that we need to focus on that have been identified in the project. So here's our project team. It's really driven, or there's a group, Institute for Market Transformation, out of DC, who is the project management. And so I still have meetings with them, online meetings, where we talk about the project. Our field team included people from Nexent, now Resource Innovations, Troy Pressler from Building Science West, who's, Jeff knows him, is one of our HERS raters, Utah Clean Energy, Kevin and Jim Myers from SWEEP, Southwest Energy Efficiency Project. Then I participated in it, and then we had support from Pacific Northwest National Labs, DOE, and Rocky Mountain Power and Dominion. So our goal was to collect field data, generate baseline compliance rates across the two states, and then develop targeted education programs. So it kind of makes sense. We'll go look at a bunch of houses, and HERS raters were one of those people, were groups that we had collect that information. And they went and looked at a bunch of houses. And so that's how we collected information. So what did they check for? They checked for envelope tightness. So that's our air barriers and those types of things. How do we determine envelope tightness? We have blower door tests, right? Window U factors and solar heat gain coefficients, They checked wall insulation, ceiling insulation, lighting, foundation insulation, and duct tightness, which again we test. Duct tightness we test with pressure testing. We pressurize the duct system. Is there anything missing in this? Did we test for everything, or did we check everything energy code-wise? What are we missing? Anybody have any idea? We didn't look at necessarily some of the compliance options. We didn't look at if someone did the ERI path or performance path. They kind of looked at the Utah code where we have a Utah 2012 res check and a 2015 res check, but they really based it on the prescriptive table. So if the climate zone had a requirement for R38, that's what they looked at. They really didn't look at if you were trading off. So I think that gave a little bit of concern for me, but I don't think it made a big difference. They did not check anything mechanical. We didn't look at load calculations. We didn't look at duct designs. We didn't look at equipment selection. We didn't look at controls. We didn't look at piping insulation. We didn't look at where the furnace is located. I know some of you, many of you have been in my classes before, and you know my opinion of ducts in attics and air handlers in attics. Horrible place to put it. If we want to do one thing to make homes more efficient in Utah is get that stuff out of the attics. And we could go on for 20 minutes about that. But anyway, those are the things they looked at. They are all basic envelope things: insulation, U factors, solar heat gain coefficients, the R values, and then the envelope testing and the duct testing. And that's where they ended. But it's still it's good, a good way to look at it. So how did they sample? This time, they just asked, they didn't ask, the statisticians got together and they decided based on the population around the state and where permits were, and they decided how many homes they should look at in each of these various areas. So for instance, if you're in St. George, they wanted to look at like 5 homes. And then they scattered it out generally based on the population, reflecting, also the construction activity, geographic, climate, and demographics. So they looked at 63 different sites, 126 different sites. So they visited sites twice. No 2 sites at the same time, but in the same city, and collected all this data. But the key on this one is no personally identifiable information was shared with DOE or Pacific Northwest National Labs. And so we were able to get that data collected. Now this project was supposed to be over, but something happened in March of 2020 that kind of slowed it down. It affected everything. And we are now in this phase where we just finished the analysis and we've started the education training phase of that. So what are our results? Now, they basically picked, did they use a Utah res check, or did they use the standard 2015 res check? And you can see that the majority of them use the Utah res check. Now, how many are familiar, by show of hands, how many are familiar with the Utah res check? Okay, probably half of you, maybe a little more. I think most of you are aware that ResCheck is a free software from Department of Energy that you can input your house. This is residential. They have a comm check for commercial, but you can input your house, and if you have a weak component in the house, say a weak wall, you can make up for it with a better window or better insulation someplace else. So it's a trade-off. You know, we have a prescriptive table, and in fact, I'm going to step away and grab this sheet real quick. Does anybody want one of these that doesn't have one? If you need one, raise your hand. And Jacqueline can bring you one. So I have this little sheet, and if you've been to any of my classes, I've shared this sheet many, many times. And this is, we put this together 7, 8 years ago. It's been updated when the code's changed a little bit, but it's a summary of the residential energy code. And if you look at this, the very first thing on there is it gives you your compliance options. And the very first compliance option is a prescriptive table. And the prescriptive table is listed on here. And it simply tells us that maybe the simplest way to build a residential house is we follow this recipe. We put R20 in the walls, we put R38 or 49 in the attic, we put 0.32 or 3.5 windows depending on climate zone, and we just follow that completely. Well, if something's weak, and if we look at this, and the perfect example is if we look at our frame walls. In all climate zones, it says we have to have minimum R20 in a wall. In climate zones 3 and 5, and in climate zone 6, we have to have 20 plus 5. Or in the other climate zones, we can have 13 plus 5. So what that's telling us is we can put R20 in the cavity, or we can put R13 in a cavity, plus 5 inches R5, 1 inch of foam on the outside. Do we build, to put R20 in the cavity, what do we have to have? 2x6. Does everybody build with 2x6? How do we get away with outbuilding with 2x6? We do res check. Well, you can put foam on the outside, that's right, but we do a res check. And what does the res check say? Well, the res check will tell us, well, for instance, in climate zone 3, we have to have a 0.35 window. So the 0.35 U factor on the window, and we want R20 in the wall. Well, they don't want to build with 2x6, they want to build with 2x4, so it's going to be R13, maybe R15 if they put the high density bats. It doesn't comply with the prescriptive table. What's the typical window we buy nowadays? What's the U factor on a typical window? Anybody, what are you seeing out there?
A lot of them in the upper 20s.
We're seeing them in the upper 20s, aren't we? The standard window now is around a 0.32. So it's better, and we can comply by doing a res check, and we trade it off. Well, my windows are better, and so they're going to offset the energy lost by a poorer performing wall with a better performing window. And it does a UA calculation and tells you if it complies or not. And so that's one of the big things that res check gives us, is that flexibility. We can maybe use 2x4, or we can do some other things, and it does give us some ability to not have to fit that recipe exactly. Now we have here this IECC Utah, so that is a 2012 res check with what I'm going to call an equipment trade-off, and I think a lot of you know what an equipment trade-off is. In 2006, with res check, you could put in a 96% efficient furnace and get credit for that. In the 2009 code, and I guess it's rightly so, because a 96% efficient furnace is significantly, almost 20%. It's 18% more efficient than the minimum efficiency required by the federal standard. So you do pick up those big savings. In 2009, the code said no more equipment trade-off. Why would the code say no more equipment trade-off?
Everybody's already supposed to have a high efficiency furnace.
Well, Dan says everybody's supposed to have a high-efficiency furnace. That's part of it, but at the code hearings, and that was the first code hearing I ever attended, How hard is it to improve a wall after the house is built? It's really hard, isn't it? And it's terribly expensive. I mean, it's easy to improve the attic, and it's not that horrible to improve the windows. But to improve the walls is very, very difficult. So we really have, and this is one of my soapbox issues with energy code, is there are certain things in a building when we build it that we have one shot to get it reasonably well. And that shot is when we build the house. And if we build a house with a poor wall, that poor wall sticks with the house for how many years?
Couple hundred.
Couple hundred. People like to say, well, it's only 100 years or whatever, but you go back east and there's homes that are 200 and 300 years old. Now, sure, not every house is going to be there, but so that was the logic behind doing away with an equipment trade-off. Well, guess what? We didn't adopt the 2009 code in Utah because of that equipment trade-off. Those interested parties chose to, we'll skip that code because we want that. And then when the 2012 code came around, it was adopted conditional upon DOE writing a res check that allows the equipment trade-off. And so we begged and pleaded and actually got DOE to write us a res check. And we still have that res check that we have to live with. And right now you can see on this, this guide, compliance options, upper left corner, first item on there, we have 5 options, and the 5th option is the Utah 2012 res check pass rate of 5%. So it's a weaker res check. You have to pass by 5%, when really, if we wanted to be more equal to the others, we'd need to pass by closer to 10% to be on parity with the others. But anyway, that's what they've used, and that's what they've looked at, and that's why we have 2 different compliance options here, when in fact, as I was trying to say before, we actually have 5 options, and we didn't look at all 5 options. We just looked at 2 of them, and then really it all referred back to that prescriptive table. And you'll see more as we get a little bit further on. So this is just some site participation numbers based on utility energy efficiency programs. And so this is, let me just summarize this real quick. I don't need to read numbers. So what's one of the easiest ways that was determined to get data? It was to talk to people like Jeff, and I don't think you did any of these, Jeff, but HERS raters, and how many are familiar with HERS raters? I think everybody's kind of familiar with a HERS rater. They go out and it's a voluntary thing that a builder does. If he wants to do Energy Star or something like that, he has to have a HERS rater come out. If you build in Daybreak, don't you have to HERS rate all your houses in Daybreak? Or
In theory, but I've seen it kind of lean away from that a lot.
that's the theory anyway. So it's a voluntary program. You have these guys, home energy raters, come out and look at your house, and they look at, during the process, you look at insulation, you look at windows, you test the house, and you give it a score. Well, the easy way to collect data is to go to the HERS raters and say, hey, do you have data on homes that you've been in? Because they've already gone there for a reason. Now, is there a flaw in that maybe, or a bias in that? Yeah, because what are we doing? We're going to homes that are trying to be a little bit more efficient. And so, as we ask the question here, maybe we do have, Jake from IMT and I, as we were putting this together, we discussed, yeah, maybe we do have a little bias in this, but it still kind of gives us a guide on where we're at. Of course, here's our climate zones and our density. Real quick, I think most of you are aware that we have our unique little climate zone 3 down here in Washington County. All this is climate zone 5, and all this is climate zone 6. And 3 is a warm, like Las Vegas. It's more a cooling market. This is a heating market. The higher the number, the colder the climate. And of course, our population density. And so we collected more data here, and maybe just 1 or 2 in Moab, very little out Duchesne, Vernal area. And then as we go down through, more in Cedar City and more in St. George area. So what did we find out? So as they ran this, they modeled the energy code, the homes that we were building to the 2018 energy code. So if we'd built to the 2018 energy code, what are the statewide saving potential based on the data they collected on that representative group of homes? And the interesting thing is, and I really didn't expect this number to be that large, the biggest number was exterior wall insulation. But as you think about it, what do we have in Utah? We have that Utah res check that allows us to build with the crappy wall, right? And so lots and lots of builders, rightly so, I don't fault them for doing that, build with a 2x4 wall. And they don't put any foam on the outside because they don't have to get it to comply. And so that's a big number. Duct leakage, that's a big number, and it would be a bigger number if they had looked at duct insulation and duct location. In fact, my personal opinion is if we had looked at ducts in attics, that would be our biggest number. And I think it would be probably over $1 million just for that one number if we looked at the heat loss and heat gain from the ducts in the attic. I don't have any empirical data on that, but it's just all the load calculations I looked at, and I've seen how much of the load goes to those in the attic. Now, in all openness and candidness, this number is flawed. In fact, I had a big discussion with Pacific Northwest National Labs and everything on this one. And this says heated basement wall insulation. And then they're saying that what they're basically saying is it's not a savings, it's a cost. They put a negative number on the savings. And I said, whoa, help me out. And they says, oh yeah, if you insulate the basement walls, you lose the free cooling that you get from the basement walls absorbing heat from your conditioned space into the 55-degree ground. So you save money in the wintertime, but it costs you money in the summertime. And they were saying that was their logic behind that. And Dan's over here going, what are they talking about? And of course, my immediate response was, where is the heat coming from that we need to remove in the basement, that the cool basement walls would suck out of where's our internal gain? Where's our gain into our basement? And we went back and forth 5 or 6 times, and they says, and they sent me this big chart on all the things they look at, and somehow they had an attic load that was being added into the basement. And so in most of my, I'm doing this just in all honesty, that this isn't a perfect study. Most of the time when I talk about guess what I do? I pull that one out and say, this is garbage. It's the old garbage in, garbage out thing that we've talked about so many times. So that's a flaw in the study, but I want to be completely candid about it. Ceiling insulation, sure, that one would make sense. We have, again, you can trade it off. You don't have to go to the full prescriptive table requirement. Envelope air leakage actually was a smaller number than I thought. Window U factors, quite small, solar heat gain coefficient quite small, and lighting almost nothing. Lighting is one of the things that, when I first became very involved in this, most of you know, I became an inspector in 2005, and in 2007, 2008 is when there was a big push nationally to build more efficient homes. And the first thing they did is they simplified the energy code and made it simpler to enforce the energy code. Larry, you remember, that's kind of when we really started enforcing energy code and talking about energy code. Before that, it was kind of just, someone might ask for a res check, but no one looked at it, no one was really concerned about it. Well, and that's because in 2006, they simplified the energy code so it'd work. And at that time, what did we have for lighting in 2007, 2008, 2009?
Incandescent bulbs.
We had incandescent bulbs, and we had, coming out, CFLs. Show of hands, anybody like CFLs?
I don't mind them. I still got some.
I've still got some outside, like in my lamp post in my front yard. I gotta see it. It turns on at night, goes off in the morning, but it's really bright.
And I base it on how much does it cost me. My energy bill is low.
Your energy bill's low, it's not worth, you're not gonna take the CFL, throw it away,
No.
and put in an
I
LED.
don't pay hardly anything.
You don't pay anything for electricity, and the bulbs last a long time typically.
Yeah,
And maybe when they fail, you put in an LED,
yes.
because what's changed with LED? Price. I did a remodel on my house, well, one of the continuous remodels on my house, but I did my family room, and I did a coffered ceiling with 2-foot square panels, you can lift out, and I wanted some dimmable little 4-inch fluorescent cans, 4 of them, located in those lift-out panels. And I think I paid $34 a piece for those back in 2009 or something like that. What would I pay today for an equivalent light bulb? $1.50? $2 maybe? So lighting has really changed. Lighting is something that, as far as energy code, it took care of itself. We really don't have to worry about it. We still have a requirement in the code that at final inspection, in Utah, it's 75% or 80% have to have high efficacy light bulbs in it. But LEDs got so cheap that builders don't move high efficiency bulbs from house to house for finals anymore, because the labor doesn't even justify the labor to do that. So the big thing one of the big takeaways is that these are two strong items up here, our duct leakage and our exterior wall insulation. I'm throwing on as personal experience and personal opinion, because we have duct leakage that we need to look at. We also need to be looking at duct insulation and how we address that. Obviously, duct leakage is so important. I just blows my mind when I find on a house that they test for duct leakage, and it passes. It's a weak standard, isn't it? Because the energy code's weakened it.
Well, we tested it at 4-way too, and that's kind of a weak point to test, because if they do not seal the boots if it's in the attic, they don't seal all the boots to the drywall.
You know what, Jeff?
That'll swim.
I'm going to have you describe this. Larry, you want to pass this over to him?
The duct testing we do at 4-way typically, and we seal off all the boots, plug them or tape them off, and test, and we get it to pass. But the true test is when we run the blower door, if they have not sealed those boots, if the ductwork is in the attic, they have not sealed it to the drywall ceiling, you would actually fail a duct leakage test at that point. Typically you'll also fail your blower door, because the air leaks around that boot and sucks right into the house, and it'll do that naturally too, just with the heat in the attic rolling through there. The other thing is that the cool air or warm air, whatever you're trying to push out that vent, bounces off that vent and bounces back into the attic. So it's a big issue there that, with attic ductwork.
I don't know if you can see what, thanks, Jeff. I don't know if you can see what I put on the board here. Here's the boot coming down through the drywall. When he tests at rough stage, the drywall isn't here. And so he seals off the boot, right? And he tests. So he just masks off the boot and he tests. But then when the house is finished, you have the drywall here. You have a register that gets put on down below, right? And if this isn't sealed and this isn't sealed, what happens? The air comes down from the boot and it curves and goes right back up into the attic. And it's a big, and it's,
attic air drops right through the vent too when the system's not running.
yeah, attic air drops down. Yeah, and these can be big deals. Yesterday we talked about return and all that stuff and how changes in pressure in your house drastically change how much air leaks in and out of a house. Well, if you have this leakage point here and your room is either negative or positive, we have a lot of leakage through that. We have a lot of leakage through lights, can lights and all these other things, not through the fixture itself, but through the open space every time they do a ceiling penetration. So, yeah, it's duct leakage is a big deal, but so is the insulation up here. What's going on up there? Now, I can't go without making a comment real quick on ducts in attics. What's the requirement for insulation in a wall? We just talked about it's 20. Insulation requirement in an attic is 38 or 49. What's the insulation requirement for a duct? 8. What two factors determine how much heat conducts through a material? The R value and the temperature difference. So we have a 75-degree house in the summertime, and we have let's say we have a 150-degree attic. Black roof, poorly ventilated, it's 150 degrees. We have a 75-degree temperature difference, but we have R49 stopping the heat flow. What's the temperature inside that duct in air conditioning mode? Air conditioning's operating. If it's 75-degree return air coming from the house and the duct doesn't leak, then we go through the air conditioning coil, the evaporator coil, and we have 55-degree air in the duct. So we have 55-degree air in the duct. We have 150 degrees in the attic. We have a 95-degree temperature difference. We have a much greater temperature difference. And how much insulation do we have? R8. So we have a quarter of the insulation, and we have 30% more temperature difference. Is there anything wrong with this picture? Like, everything's wrong with this picture. Ducts don't belong exposed in attics. But that's missing from this, but it's something that I'm going to focus on every time I talk about it. So the key takeaways on this, and we'll move along here. We didn't look at HVAC systems. Exterior walls and duct leakage is more than 70%. Off-the-shelf key measures, windows and lighting are highly compliant, while skilled installation-based measures, wall insulation and duct tightness have room for improvement. What is installation a skill? Absolutely, to do it right, it's a big, big deal. Air leakage is quite low, which big red flag. If our air leakage is low, what are we concerned about? Mechanical ventilation. If your house is tight, we really need to worry about mechanical ventilation. We need to have mechanical ventilation. But our code right now, and I've got my fingers crossed that this will be fixed next year. If this is the only thing we get in the adoption of the 21 code, I'll be a happy guy, is that we will not have a choice on mechanical ventilation. You'll have to mechanically ventilate every house coming up next year. Now, what's mechanical ventilation? In a home, it can be as simple as a high-quality fart fan.
Wow. Some guys forget to put the high-quality one in, so they hardwire the cheap one in.
The cheap bath fan doesn't work. If you look at this on the back here, whole house ventilation fans need to be high efficacy fans. And you know what? I'm going to say brand names. Panasonic has kind of led the way with real efficient fans that draw about as much as a doorbell transformer and can continuously run all the time. You just hardwire it in your master bathroom to run all the time and just let it continuously ventilate. There's enough leakage to replace the air, and we have mechanical ventilation. It doesn't cost a lot. I have that in my master bathroom. I have another bathroom upstairs that I had one of those Panasonics, but I bought at Costco right over here. I think it's made by Delta.
Della makes pretty good too.
And I paid $80 for it. And it has a built-in humidity sensor, and you know, it's a pretty nice little fan. It doesn't have all the features that the Panasonic does, but it's a pretty nice little fan. And I can just leave it running at, 15, 20 CFM, and then when it senses humidity, it jumps up to 50 or 70 CFM. Mechanical ventilation. Our most broken thing in our code here in Utah right now is blower door testing as an option, and the trigger for mechanical ventilation is tied to the blower door test, and we just don't have a lot of it occurring unless the builder just chooses to do it. So if you have any concerns or questions on mechanical,
Blower door test is an option.
Jeff, yes, blower door test is an option in Utah right now, Jeff. You can do the inspection checklist or you can do a blower door test, right? And I'm not going to ask builders here, but I bet most of them, if the jurisdiction asks for it, do the inspection checklist. And if you do an inspection checklist, you don't have a blower door test that can trigger the requirement for mechanical ventilation.
That is having to foam your rim joist.
The key on that is foam your rim joist. Jeff brings up a good point. If there's a cup,
Everything else on that list is pretty easy to foam.
yeah, pretty easy. Mark LaLiberte does this, and so I've kind of stolen this from him. When you come to a class like this, I always think, and I do what he says, and that is, pick something that you want to do to make your homes a little bit better. And one of them is mechanical ventilation, and one of them is spray foam your rim joists. Because your rim joists always leak, and rim joists, I do some expert witness work. I see so much mold on rim joists because moisture gets up in those joist spaces and migrates to the cold rim joists that is insulated really poorly, and it's insulated with a piece of fiberglass bat that they've just took a stick to shove it up there. And fiberglass bat stops no moisture, and that is one of the most common places that I see mold in relatively new houses is the rim joists. And if you spray 2 inches of closed cell foam all the way around on your rim joists, yeah, it's going to cost a few bucks, but those problems will be gone. So it's a big thing. But the mechanical ventilation helps that because condensation, if you get that psychrometric chart out, condensation occurs at higher temperatures when you have higher levels of humidity within the home. So if you can keep the humidity levels, you control the humidity levels, you also lessen the chance of condensation and damage in the home. Attics and ceilings are generally compliant. Basement walls are a little low. Generally, we see basement walls in unfinished basements, they use a blanket, and they have R11 and R19 bats, and everybody puts 11s or something like that, and it's just a little bit short of what's supposed to be there. Please.
I've got a good question.
Larry, I'm gonna ask you to take that back.
Thank you, Larry, you do a good job.
Larry and I are good friends from many years back, aren't we, though?
Good.
But most of you are.
You know, you mentioned the fact of spraying foam around the rim joist, but that just seals it off from the inside for allowing anything from the inside coming through. Where you want to stop it's on the outside of the wall. So why don't we go ahead, get rid of the foam and just do the flashing from the exterior of the wall and finish it off that way?
I mean, with your air barriers and
Yes.
stuff like that.
Everything, all the way down through to the foundation point.
That,
It
That-
doesn't
that-
stop the cold from getting on that rim joist and the water condensing on it.
That, no, we're talking about it on the outside. If it stops it there, it stops it.
This is
The
moisture-
foam's on the inside.
This is moisture condensation from inside the home.
Oh, that's just.
Showering, washing,
we're talking,
there.
yeah,
but
exactly.
You're talking about 80% of the moisture that moves back and forth through that wall comes from the exterior,
Yeah.
not from what we're doing with washing or showering.
You're absolutely correct.
Yes, I am.
That,
So
but,
there we go.
but, that other 20%, now, there's no question, the number one, and I think your number's accurate, our number one moisture intrusion problem is from outside.
That's correct.
No question about it. I mean, we see it getting behind stucco, we see it all over the place. We see improper flashing on roof lines, we see all those things. However, when we do all those things right, if we have a cold surface inside and we don't control our humidity inside, we have a cause for condensation. I was involved, well, I wasn't directly involved, but another guy I work with, it was his case. It was some townhomes, a whole bunch of townhomes. And they had some problems with the chimneys that they had built on the outside of the building. And they'd put, I call it lick and stick stone, just the cultured stone that they'd had some problems. And so guess what they did? They put ice and water shield over the whole thing all the way up. No water came from outside, but guess what happened from inside? The OSB literally rotted away because they weren't controlling the humidity inside.
Yeah, it's got to be a balance.
It's a balance, there's no
And
question.
that's the point here. We go ahead and say the code allows us to put, or we're going to, fix the problem by putting a bead of caulk on the inside or foam, when actually the majority of the problem stems from the exterior. We're saying that we've got a panacea that we're fixing with just a Band-Aid, when we take care of only 20% of what's going to move through that wall.
Well,
So-
yeah, no, I don't disagree at all.
That's it.
No, I don't disagree at all, and I think you make a very valid point. And, with my career as a building inspector, it was one of the big deals, was our weather barriers and our moisture control, and that's a huge deal. And that, if you don't address that, you have a problem on every house. If you don't do that right, you have a problem on every house. What I'm focusing on the energy side of it, and it ties in with the question on blower door testing versus the inspection checklist. The inspection checklist specifically says, and it's for the 20%, if you don't blower door test, well, actually the code says you'll do the checklist and you'll blower door test. We just amended it. The legislature thinks they can amend building science sometimes, but if you go through the table, it says rim joists must have an air barrier on all 6 sides of the insulation. And to do that, you put the insulation in. Do you take a piece of Tyvek and cut it and fit it over the insulation and caulk around the edges, or a piece of OSB? That's just not feasible. That's what the code says. It has to have an air barrier. So what's the easiest way to put an air barrier on your rim joist? Spray foam.
And I agree with him, Brett. I have not been involved in a construction defects case yet that started. with moisture vapor coming from inside the house. We find it later, but it always starts with bulk moisture penetration from the outside.
No
Starts
question.
everything, but as you get involved in there, you may get up above bathrooms where they haven't been ventilated properly. You've got all kinds of mold up in the ceilings and stuff because it's that condensation that's happening.
Yeah, yeah. No, there's no question that there are more than one way to skin the
Kind of two different
cat.
things. That the bulk water is a huge issue.
The bulk water is number one.
Yeah.
I don't disagree. I never will disagree with that because it is number one. I've seen so much more of that than anything else. And millions of dollars of damage because of bulk moisture. Hundreds of millions. But anyway, I'm going to skip through these. What time did you say I'm supposed to? I'm sorry? 12? Lunch is going to be here at 12? Okay, well, I'm going to go a few minutes after 12, if that's okay. We have, by the way, these slides are all posted on the Utah Energy Code website, or will be posted on the Utah Energy Code website. Real quick, I'm just going to fly through these. Here we have the code requirement for lighting, and here's what they've measured. Almost 100% have all high-efficacy light bulbs. Just a couple here and there did not. So our draft training plan,
It's a
and
good example of the lack of insulation on that. It's that,
yeah.
that work that's
Isn't that horrible? There's so much wrong with this thing, including this is not an insulated duct.
when they do insulate it, they put a piece of bubble wrap on it that basically does nothing.
Does nothing. Now, so who's our target? And I added these numbers last night because I thought it would be, and I'm throwing these out. I might not be right, but I think the number one is building officials. The code officials are the first ones that need to train because they need to uniformly enforce the code all across the state. I understand a builder's frustration that he builds in one place and they don't ask him to do anything. He builds someplace else and they're making him do all this stuff. And then there's other code officials that require you to do stuff that isn't in the code. I worked with an inspector, and Shane knows who he is, and I'd get a call, or we'd talk about it in staff meeting, and he'd call something, and we'd talk about it, and one of us, myself or Shane or someone would say, well, that's not in the code. And his response, well, it should be. Well, if it should be, then go back and get it in the code, but it's not in the code. So anyway, that's our first line, and our hope is that we can train these guys so that they do it uniformly. I think it's important that the design professionals understand it so that we have the plans closer to right or right the first time out. The home builders understand it, the subcontractors understand it, and even the suppliers understand it. A supplier shouldn't be selling a product that doesn't comply. Question over here.
I can talk.
But they can't hear you, Dave.
So Brent, if you see that octopus as a building inspector, what should I do?
Okay, as an inspector, what should he do? Require all the sheet metal to be insulated minimum R8. Require all the flex duct to be installed in accordance with the manufacturer's instructions, no kinks, supported, all those things. Sealed, and number one, it's in the attic, it has to be tested. Ryan?
On the bare ductwork though, also be careful, because it could be lined. Look for
Hey.
weld marks. On the bare insulation, you've also got to be careful as an inspector, because that duct could be lined on the interior.
That's right.
We line it on the interior so we can use self-sealing collars and have a lot better connection, and we don't have to cut the outside wrap and have all of those
That's great.
connections. So if it is lined, you'll generally see little weld
Welds.
marks every 12 inches or so.
Do you guys have R8?
Yeah,
Interior insulation?
yeah, we do 2-inch
2-inch duct liner.
liner is what we do, and we've had a lot better luck on the ceiling side and the insulation side doing it that way.
And I love that. Yeah, that's great.
And we have been called by some building officials, as they just don't understand that. We try to cut one of the circles with the insulation and screw it to the duct so they see that it's lined. but
Perfect.
That doesn't always happen.
Yeah. Because I look for those because, of course, I was an HVAC guy, and I welded millions of those stupid pins on the duct, and you could see them. And so I looked for those, and if I saw them, I asked, or I went to the return boxes that were also insulated to see if it was 2 inches. And typically it was 1 inch, and it was 4.2. So that's a great comment.
It's almost touching the roof deck, though.
Yeah, it's probably going up to a rooftop unit or something. It's a terrible installation.
Well, I see them like this, they don't have enough room to put a little tiny plenum up there and get all the ductwork, they run it all the way to the roof deck, and it's like, no, you need space there, you gotta get this.
They need to roll it
Right.
horizontally and then hook on. So our current plan is to focus on compliance with current codes, uniform level of enforcement across the state. That's our big thing. And I'm going to wrap up here pretty quick here. My goal as a trainer with OED and providing this energy code training, my goal is to get into building departments and to get into every building department. I've done a couple of them. It went very, very well. Asked them, so what are your challenges with energy code? What do you need help with? Several have sent me a list. I put together information based on their list, and then I go out. Or in the past months, we've done some of them on Zoom, and we just sit down with the staff, and we discuss that. Dave, I even went to where the place we used to work and made some big progress there. Of course, I want to see the stuff get out of the attic, or you encapsulate the attic. It is based a lot on the prescriptive table, which isn't, I don't think it's the best way to do a study. And we need to increase the education so that we have all of these people, everybody involved, doing a little bit better. Now, before class started, we talked a little bit about it, and I think it's worth repeating here. These are all homes recently built that fail to meet the energy code. And we can say, well, whose fault is it? And I've actually done a class here on it. So who ultimately is the most responsible for building a home in compliance with the energy code?
General contractor.
Okay, general contractor. I 50% agree. He says general contractor. And why is the general contractor supposed to?
Well, 'cause he's responsible for making sure the home meets everything in the code, that's what the building officials will say.
Okay,
They come in, that's why they always get released from court.
I would say building officials, because they ultimately checking what they built, and if they don't have that check, it's basically nothing there.
okay, he says building official. You're 50% right too.
Subcontractor needs to, because he's being paid to install it as per the energy code, and if he doesn't do it, then he shouldn't be paid.
He gets
Okay.
named in the lawsuit underneath the general contractor.
Okay, let me just tell you real quick when I say Utah code, if you want to look for everything that the legislature passed, you Google Utah code, and it gives you all these chapters of all the regulations, all the laws that the state has passed. And if you go to Utah code, and I don't know the numbers off the top of my head, but you can go to requirements or the law, the requirements for people that hold an inspector's license and people that are contractors. There's a section for each one of these groups. If you hold a license in Utah, you are required as a contractor to build in compliance with the adopted codes. It doesn't say anything in there, and my experience with the courts is you will get nowhere by saying, well, it passed inspection. There's nothing in the Utah code that says the builder has to build in accordance with what the inspector makes him do. It's in accordance with the adopted codes. So we have that, and then we have contractors. Everybody holds a contractor's license. Same thing. Well, the contractor's license, the contractors have to do that, but then for the inspectors, it's the same thing. They are to enforce the adopted code. And if either group fails to do that, they are guilty of unprofessional conduct. And then the code goes on to talk about what may result from unprofessional conduct. And so, really, it's everybody's responsibility. If you're involved in it, it's your responsibility. The rest of my slides are just going through the graphs. I wanted to stop on one last one, and then I'm not going to do anything with the rest of them. Can you see those fairly well? This is, I mentioned Marc LaLiberte, construction instruction earlier, and if you don't have this app on your phone, you ought to get it. I have 3 wall assemblies, but since so much of what we're talking about today is the wall assembly. This is the calculation done for an R15 wall with R5 continuous insulation on the exterior. This one's an R21 wall with R5 on the exterior. And this is an R30 wall that's all spray foam in the cavity. Spray polyurethane foam. And I see you shaking heads. Is this horribly expensive? Terribly. But even what makes it more ridiculous is, let's look down here. 25% framing, R5 on the exterior, R15 in the cavity. The assembly R value is 1606. So taking into account the wood and everything like that, that's your actual average R value for that assembly. 2x6 wall, you kind of R21 bat in it, you put 1 inch of foam on the exterior, 20.26. That's not a bad, that's the actual, it's got 21 in the cavity, but that foam really helps it a lot. We could take the foam out and see, the foam on the exterior and see how it goes. Here's that wall that you spent how many thousands of dollars spraying foam in the 2x6 cavity. Is 17.27. It's barely better than the 2x4 wall with 1 inch of foam on the outside. This one is better. 2x6 with a standard bat in the cavity and 1 inch of foam on the outside. What does this tell us? If you really want to make a good exterior wall, put some foam on the outside. Yeah, all the thermal bridging is gone. And guess what? If you put foam on the outside, you don't have to spray foam in the rim joist.
Dew point's way out.
Your dew point on all your interior surfaces is plenty high that we're not going to have any problems. So I'm going to leave it with that. I'm just going to go to the end because these are just tables that we don't need to look at, and leave my contact information there. Feel free to reach out. The slides are available on the website, and if we don't have any questions, we'll break for lunch. I know that's a loaded question to ask someone if they have questions at lunchtime because no one's going to ask. Thanks. Sure. We have a comment. Larry, you want to wrap
What
that?
do you think that chances basically if we can pass the new code in the legislative session? Wait for the mic, please.
Oh, I can repeat it. He asked, what's the chances that we're going to adopt the 21 code? Is that correct?
That's correct.
It's okay, Larry. We went through months and months and months of reviewing it and reviewing what the Utah home builders proposed to amend. And I think we came up with a reasonably good package. I'm not sure what kind of surprises might be pulled at the last minute. You know, it's gone through the process that the mechanical advisory committees and all the other committees have, you know, made recommendations. The Uniform Building Code Commission, I think, has presented it to the Business and Labor Interim Committee at the legislature. I have a copy of what supposedly was being submitted, and there's just a couple of little things that I don't like, but I think we'll adopt. We're going to have similar amendments as we have now. We'll still have a Utah 2012 res check, but maybe you have to pass by a higher rate. There's a lot of stuff in the 21 code, you know, solar ready EV car stuff. I don't think that stuff's gonna make it into the code, or it's gonna be limited. There's a lot of lighting controls that are in the, you know, occupancy sensors and stuff like that that are in the residential code in 21. And I don't think those will survive. Ryan?
As of yesterday, none of that's gone to ledge research though, to be published, which, and Tom Peterson was told to go talk to the legislator. So there may be something in the works.
Yeah, there's stuff in the works, you know what I mean? And has anybody ever been to the legislature while they're in interim meetings and stuff like that? You know, it goes to, well, when they're in session, it's just the Business and Labor Committee meeting. It's interim when they're not in session. But when the legislature's in session, someone, if they're in a powerful position, can change it right then. It's approved and it goes to the floor. So I'm not going to predict anything, but I think we're going to get something. We will adopt all the commercial codes, the IBC, all those, with very little amendment. The residential is going to be kind of a mess, and we're going to have a big pile of amendments, and it's going to be pages and pages and pages of amendments on the residential side. And hopefully we're trying to protect the homeowner a little bit through the process. So I wish I had a better answer, but that's kind of where we're at.
So you think that will be improving in the envelope or basically mechanical systems, or where do you see the biggest improvement?
The biggest improvement I think we'll see is going to be in probably mechanical ventilation, and that's probably the biggest one that I see. You know, a lot of some of the other stuff might survive a little bit, you know, but I think it's going to be fairly close to what we have right now, you know, with maybe just some incremental improvements, you know, across the board. Attic insulation is supposed to go to R60, you know, all jump up a step, and I don't think that's going to happen, and I don't have a lot of heartburn with that. Once you get to 49, it's so little. So I don't know. As we get close, and as soon as we have the session, I'll be putting a class together on the new, whatever's new. Okay, thanks. Lunchtime.
A lot of houses being built though without Energy Hill trusses that are going R30 insulation, and nobody's saying anything about it.
Yeah, Jeff made a comment, and I should have said this earlier. If you're a builder and you want to do one of those things that's really good, put a high heel truss on the house, so you can get full depth insulation all the way to the outside walls. Costs you a few bucks. Truss manufacturers say it's not that much, it's just a few more board feet. And, you know, that's one of the mold places. And it also helps with ice dams, because you don't have so much melting there. Okay. Cool. Thank you.
Perfect. Well, welcome everyone, and thanks for joining. This is a good opportunity to get together and talk about energy code enforcement, and kind of some lessons learned in the field. My name's Chris Cox. I'm PE. I'm a mechanical engineer by trade. I've been in the energy efficiency and energy code type industry for about 15 years now, so quite a bit of experience. Here joining me is Sam Hartman. He works for Resource Innovations. He's kind of filling in for Scott. Maybe on the flyer you noticed Scott Dwyer was going to join, but he actually got COVID, so couldn't bring him here. Where Sam's value is he actually is he QC's 10,000 buildings that come through the ThermWise Builder program, the ThermWise rebates program. He's the QA QC reviewer, so he's looked at 7,000 REM models over the course of a year, so he sees a lot of what's in the field. He's gone and done a lot of Raider ride-alongs, things like that. So he's fairly well versed in what Utah's construction market looks like. So I thought he'd be a good backfill for Scott Dwyer. So Sam, you want to give a quick intro for yourself?
Yeah, Sam Hartman with Resource Innovations. I'm a mechanical engineer in PE as well. I've been in the energy efficiency industry for about 5 years now. So yeah, I'll just kind of tell you guys what I see in the field for on the residential side.
Yeah, and also he's an Iowa native that's been here for about a year and just loving the Utah outdoor rec culture. So kind of a fun thing with Sam here. So the topic Scott and I talked about was try to keep it simple, kind of the KISS, keep it simple, stupid energy code principle. We talk a lot about energy codes, and a lot of folks get into the weeds in this energy efficiency science, and I think it confuses people. So we're trying to bring it down a level that almost anybody can understand, and we're going to give a couple of cases of some experiences we've had working with just smaller, like Habitat for Humanity, and we worked with some high school kids with the Davis School District. How did they solve some of these challenges that supposedly, these builders and subs are struggling with meeting when it comes to the energy code? So that's really what we want to do is we want to keep it simple energy code. And this kind of comes from Scott here. I might actually read what Scott has where he's not here to actually speak here. Code is the lowest passing grade. It's not the goal. Maybe school wasn't your strong suit, so pass-fail was okay to get through. But now building is your profession and your reputation is on the line. Become a professional respected for your work and leave a legacy of projects you can be proud of. And I think that's a great goal for us folks in this field. Building is a craft, but informed by science, and your building is a system, not just a bunch of systems put together that don't interact. Each impacts the other. One trade impacts the other. You wouldn't want a high-performance engine in a car with a code-compliant brake or transmission where the installing subcontractor hoped his new guy could learn on your car. One question he asked, this is for the contractors, are you happy with your subs and confident that they will do their work in a way that will exceed the code requirements or at least meet their code requirements? Insulation, sealing, water moisture control, air quality, and energy efficiency. Something that Scott kind of pointed out is these are things that I'm not even actually a residential home builder or anything, but I've heard all of these things. He says something that he's heard out there a lot is that's how we've always done it. Let's not do it that way. So when we're seeing issues with not meeting the energy code on roof insulation, we've always just blown in whatever and missed the energy code target. So let's get away from that this is how we've always done it mindset and just go, let's do it right. It costs too much to increase energy efficiency, and it will price out the average homeowner. I think there are some cases where that may be true, but in general, going from an R39 to up to the code requirement of R48 or 49, that's not a big adder. So examples like that are good to keep in mind when you're thinking, does it really cost too much to increase energy efficiency? I don't think so. Another thing is energy code isn't really enforced, so if others don't have to comply, why should I? I'd like to think the purpose and the intent of these programs and code trainings is we absolutely want 100% compliance, and that's what we're striving for. That's why we're here. So that really is an acceptable we don't want to hear that in the field. And then lastly, it's too complicated to know if I'm in compliance. I think in some cases, sometimes it is, but in general, if you've been in the home building industry for 5 years, 10 years, it shouldn't be. There's nothing too complicated about it in my mind. So one of the examples I want to give here is some work we did with the high school students down at Davis High School. I bet none of you in the room know, but they were actually awarded special honors as part of the DOE's Home Innovation Awards in 2021. So if you see, we've got Dave Milliken and Jeremiah and some other folks there. Congratulate them on that huge achievement that the Energy Secretary of the United States said the work that you're doing, building codes well beyond, or building homes well beyond just energy code, was humongous. And as the Energy Secretary of the entire U.S., want to give you this special honors announcement, I thought that was very big. So the experience here is what I want to share with how some of the challenges that we've seen on those projects and how we were able to achieve them, as well as some work we've done with Habitat for Humanity, with just volunteers. Usually we're working with AmeriCorps to build these buildings and go through these challenges. So that's kind of the intent. Sam and I actually working on Habitat. One of the problems we've had with Habitat for Humanity was actually so it wasn't that they didn't do 100% LEDs. Everybody's doing 100% LEDs. It's the cheapest option. And I think Brent's message was clear that LEDs are fairly common. But what we were seeing is that any recessed lights or can lights, they're not actually being gasketed and held up there tight. So when we ran the blower door test, we were seeing with the IR camera, we were seeing a lot of issues with air leakage at all of the can lights. And we've actually seen that on most projects that we've done where we're having to go back and talk about gasketing and tightening up those springs if it's spring held or enforced. So that was a big issue that we've seen. Brent, do you have anything to add with just sealing up the lights or anything to add with the lights?
Well, yeah, this ties directly with what I talked about, my very crude sketch there on the board behind you. The same thing happens
Perfect.
at a boot, an HVAC boot.
Yep.
Anytime you penetrate that ceiling, which is your air barrier at the top level,
Yeah.
you're going to have a leak if you don't have it gasketed or caulked or some way.
Mm-hmm. Anybody else in the audience, any experience with, how did you achieve, and kind of the intent of this is, we want to get up, what are the easy fixes, easy practices? If there's something simple and it's the fix, is there any examples of anybody in the crowd that just goes, on can lights or even the boots, this is what I've seen work really well. We'd like a little bit of input. Is there anybody in the field with some good experience addressing that item? It sounds like it's a challenge. So it's something to look,
Yeah. I was talking to a builder the other day, and as soon as the lids go in, he sends his insulator up there with just the cartridge guns, and they foam around, not spray an inch or whatever over the whole lid like you can do to really seal it up.
Yep.
But they go up with just that, the small
Yep, it's like
gun
a can, yeah.
and just go around and hit everything from above.
And that would solve it.
I think that's a pretty good way to do it.
Easy to do it, it's cheap. It maybe changes the way they're doing the build because you have to kind of time that. Like you can't do it after they've blown in the insulation, but you can do that just because, hey, once you put them in, just run up there. That's part of our building practice. That's how we do it. Solves the problem.
And they even do top plates and stuff like that at the
Yep.
same time.
That's perfect.
I'll just add, it might seem like it's a pretty minor issue, but like most of the houses I've been in, when you set up a blower door, you can feel the air sucking all the way around the can light. And if you have 10, 20, sometimes more can lights in a house, it's going to add up to make a pretty significant difference in the total leakage.
Yeah, one example actually. How many did we had? Maybe 8 can like recessed lights on this job. None of them were insulated very well. I think after we sealed them off, we got a full 1 ACH, like a full reduction of 1 ACH on the blower door test. So, it's kind of going back to that simple, easy idea is that just doing that right solved, it took you from, you weren't in code compliance. They were, let's say they were at a 5.5 or whatever. Now they're below that. That's a good way to just a simple practice, especially taking what Brent's talking about on just a simple change the way you build it, that once you put those in, go up, spray them, caulk them, and you're done. You don't have to worry about that one ACH, that we saw, so.
And it'll save you time later on chasing around leaks if you have issues later on.
Yep. Another example of this is an issue we see a lot of, and this really came to light when we used an aero barrier product. I think a lot of you folks know what an aero barrier is. Was essentially when they're sealing the home after they mud the drywall, they're going to inject kind of like a plastic polymer type base material into the air and force it through those cracks, and it's going to seal up all those cracks. What was funny is because there's a red dye in that polymer, we actually saw where the air seals were, and the seal plate was humongous, pretty much all along the air seal. There was a good, 1/4 inch bead of this material that we were seeing. So we knew that the home air sealing, the seal plate, was going to be an issue for our next. We had another build happening right at the same time, so we knew out of the gate, we already know we have problems with the sill plate. Why don't we get it foam gasketed, caulked, things like that? Is there anything that we should add on this one? Is something you've seen with the sill plate?
Just an aero barrier. It's amazing how well it works.
Well, it is. But we actually, that home was so leaky. I want to say it was somewhere around, let's say 15 plus ACH. Out of the gate. It was volunteer. You got to keep in mind, simple, stupid. This was built by AmeriCorps volunteer labor, so not the best framers. And what we found was, and this actually came talking to the aero barrier rep, is that because it was so leaky, we would have had a better outcome with the aero barrier product had we actually had it a little tighter. When you have a really leaky home, the aero barrier product's still great, still get you down to that, sub 2 ACH, no problem. But it's going to be even more effective if you can get it down to a reasonable 5 ACH to start with as your base. So that's a lesson we learned on that.
And just something I've heard from builders is that there's the air seal is it's more effective for smaller leaks, and I think there's a minimum size that it can even plug. Maybe but I've heard maybe half-inch. Okay. So if you can make sure any bigger leaks are addressed first, then it'll do a better job of sealing up the smaller ones.
Yeah.
I don't know if everybody's familiar with aero barrier. If you're not, you need to go to YouTube and watch, because they set up these misters and then pressurize the house and just push it all over. But you pay based on how long you have to run it. And so if you have big leaks, it has to run a long time to seal the big leaks. So if you still want to put the sill seal, you still want to do all those basic things that you've been doing all along and addressing the big cracks and leaks so that it can fill up the little ones. Otherwise, it's really gets expensive in a hurry.
Yep. Yeah, absolutely. Luckily on the Habitat job, we were volunteer basis, so we didn't worry too much about that. But he did let us know that you just be glad you're not a production builder.
Chris, I see a lot of the leaks, I do a lot of blower testing.
Yeah.
A lot of leaks I see are at that, of course, your mud seal, the foundation's never flat.
No.
Then you tighten those bolts down, that puts a hump in the mud seal plate, then you put an engineered piece of wood on it that's straight.
Yep.
You get those gaps. I've been telling my builders lately, just get your framer, he's got it there sitting there, get the glue out, put a big bead of glue there when he sits that rim joist on,
Yep.
and seal that up now.
Yep.
You're gonna save yourself a lot of money in the long run. It's cheaper than having the insulators come in and redo it later.
Oh yeah. Oh yeah.
It helps a lot.
Oh yeah. No,
The rim joist area is the leakiest area per square foot on any home typically.
I agree. Yeah, no, I agree. And this is kind of a side note. There's this new IRA Act that's going to be increasing the amount of incentive from the federal government for getting things like Energy Star compliance, which are really requiring these blower door tests. So if you have any builders that are trying to leverage that and they are going to require the blower door test, it's definitely those lessons learned, you got to share them with the builders just so it's not a headache. And especially, there's going to be a lot of money riding on some of these now with those federal incentives. We're going to see a lot more blower door tests done, and we got to be educating our builders on really, these best practices. Something like that solve the issue. So, great. I appreciate it. And anybody else who wants to chime in, that's the purpose of this. Is we want those lessons learned and best practices. So, I appreciate you sharing. Okay, I think we got the sill plate. Another thing we're seeing. This is just another example of when you do run that IR camera, you see a lot of issues with the sill plate. It's not uncommon to have issues there. Another issue that we saw, and I'm curious because we are working with high school students and volunteers, maybe it's unique to Salmoni's experience, but I'm curious if what you're seeing in the field when you're doing the blower door test, are we seeing doors that are installed that are not plumb level and square? Is that common? That is common. And what's the remedy there? Because we actually have some that you can see visible light, which is so bad. You're getting visible light. Yeah, I mean, you see a lot of it. Brent, do you have any comments on the plumb level of the door?
Just a little craftsmanship, just a little quality.
Yeah.
As busy as everybody is right now.
Yeah.
I think we're having people that don't have the skill set.
Yeah. So even our big production, so we're working with a big production builder, you're seeing that on 1 in 5 houses, 2 in 5 houses, or every house?
I mean, this would be very typical. In fact, that looks pretty good compared to a lot of houses. It's just, the quality. And unfortunately, we really need a slowdown in the economy. We need construction to slow down.
Yeah.
So we can get some good qualified field people out there again.
Yeah, we added 40.
It happened back in 08, when we had the big
Yeah.
crunch there. We got rid of a lot of the riffraff, and we started getting some better quality people there for quite a while.
Yeah.
And then it took off. During COVID is when it really took off.
Yeah. I looked at the Kim Gardner Institute. They show the number of permits pulled, and I saw last year that there's somewhere we added 40,000 new homes last year, which is just insane. I think historically we've been closer to the 20,000 mark, 25,000 mark. So I'm guessing with that increased volume, the lower quality, harder to find good labor, I'd imagine that increased the amount of times we're seeing this specific issue. You had a comment, yeah.
I had a couple of comments, just to step back a little bit. So my background is as a general contractor.
Mm-hmm.
Hang on, Shane.
So my background is primarily as a general contractor. My dad was a general, my mom's a real estate broker, so I got into it early on, in the late 80s.
Yeah.
I think a lot of it goes to what Brent's saying as far as knowledge and knowing some of that. Just as an example, though, the last house. So I switched over to where now I'm, on the. I do fire plan review for the state.
Okay.
I've been, got all my inspection stuff done, inspecting, plan review. The last house that I built as a general, I was more of a paper contractor where I wasn't there all the time, which is what I used to be.
Yeah.
But having good subs on that house, so it's maybe a, 2,000 square foot on the main, full basement, attic trusses on the house. And I had subs that I was confident with. I didn't do anything special. Had a blower door on the house, and the only thing I told the homeowners was like, if you want to take some time and maybe caulk the lid, or do some things like that, you could do that, but I wouldn't really worry about it. Let's just see what it comes in at,
Yeah.
So it was 2.47 on a stuccoed exterior house. I thought I hadn't done really anything above and beyond, but I think part of it it goes to, having good subs, knowing these things that you can do, or the way you build. The quality is a big difference, because I know looking at tract homes versus things that maybe, Maggleby's or some of these other guys that are doing that, your name is on the line, and it means a lot to you, makes a big difference, and versus stuff like this where, because I've seen this same thing too, where where the colleges or the tech schools are doing things like that, and they just don't have the
Experience.
expertise or
Yeah.
understanding of why, you're going back there after it's been shimmed and hung and foaming all your exterior penetrations and doors and windows and everything, and what a good window that's been sealed and caulked and foamed looks like versus, oh, they've just put foam there that really doesn't even connect to the window frame and doesn't connect to the
Yeah.
wall or whatever, so it's just looks like it's been foamed, but it's not really doing anything. So that's
Yeah.
my input. So
No, I appreciate it, and I'm glad you brought up the concept with the subs. I'm actually going to revisit that one because I think it's an interesting topic, and I don't really have a solution, but I want to talk a little bit about it with the group because I think that's actually an area that we could improve upon. But I'd like to get the kind of community feedback on that. All right, this is another one we've seen roof attic. So we heard Brent's presentation, and apparently we're not putting enough attic insulation into the homes to meet the energy code. But something that we've seen, and we're a little bit surprised, especially being mechanical engineer by trade, not a builder, but to not be seeing those raised heel trusses all the time is a little bit surprising. To me, especially where the energy code said, so where section 402 of the energy code require R49 insulation in the ceiling, installing R38 over 100% of the ceiling area requiring insulation shall be deemed to satisfy the requirement of R49 insulation wherever the full height of uncompressed R38 insulation extends over the wall top plate at the eaves. The thing with the R38 over the top plate, you need, depending on what material you're insulating with, you're needing 10 inches, 12 inches, and I'm not seeing as many raised steel trusses as I think I should. Is that what the field inspectors are seeing? Okay. Yeah. Interesting. Yeah.
Well, like the code says, R49.
Go ahead.
They could drop it to 38 if they had a raised steel truss. So the code's based on cracked trusses.
One of the main issues that I've seen, and I've been in the industry for quite a while as a distributor and a manufacturer's rep, is the fixation with continuing on with fiberglass insulation as the primary insulator and not building into more residential plans a cool roof number one, and also including foam insulation, board insulation, even at the thinnest material, ½ inch, on the interior side of the room at the lid point underneath the drywall.
Yeah.
Can dramatically change the building. It's vapor transmission, it's airflow, and it's thermal.
Yeah. Are you Ryan Rentmeister by chance? No. Ryan, you helped us out on the Davis job, and you. Yeah, and I know you did some interesting stuff with the foam. Do you have anything to add with? Because you. No.
I did mechanical for that.
Oh, okay. Anything to add, Brent, on the raised heel truss on that?
They need to do it. I mean, what does it do to ice dams? It minimizes ice dams. It minimizes mold on the exterior in showers. Just do it.
Yeah, and it seems like we actually priced one job where we caught it early on in the design, and we were like, hey, can we add this raised heel truss? It wasn't very expensive even. I remember the cost adder was kind of minimal, and we're like, oh yeah, that makes sense. Let's just do it. So I'm a little bit surprised. It just almost seems like more of an oversight. I'm not necessarily sure how to get it into the builders, into the production homes, into saying, this is a minimal change. Can we do the raised hill?
The one thing I've heard from builders on raised heel is it adds about a foot of exterior cladding.
Yeah.
Whether it's siding or stucco or whatever
Yeah.
on the exterior. But I think the benefits are just, we don't understand the benefits is what we're seeing with the people out there.
Yeah.
It's
Yeah.
just, it's a no-brainer if you think about it.
Yeah, and when I'm thinking comfort in my own home or homes that I'm in, I'm usually thinking I'm going to be less comfortable on the perimeters, and I think the lack of a raised hill is adding that to the whole. I've got the windows and the penetrations, but it's generally on that perimeter of the home. You just feel those drafts. It feels colder, and I think this is one area where you could actually improve the comfort in the home. This goes beyond, I guess, just the energy code, but into the comfort and just long-term reliability and robustness of the home. So we as part of the rebate programs, we get out and do a lot of inspections on insulation grades and just trying to verify, well, if they put it in the REM model as a grade 1, was it a grade 1, and things like that. And something I wanted to share, and this is kind of a concept idea that goes back to the subs concept. So I worked with the AmeriCorps groups on the Habitat for Humanity project, and it was about, let's call it 6 individuals, and I had to raise a hand. How many of you have ever installed insulation? And they said none of them, 0 of them. And I was like, all right, well, the thing we're going to do here is let's not think about it as something we're just stuffing in real quick. Think about this as we're going to kind of be building a puzzle. When you see some plumbing or electrical wire, we're gonna take our blades. I gave them all blades and safety gloves because they are inexperienced AmeriCorps volunteers. We're just gonna slice it and we're gonna put these in almost like a puzzle. And the work I saw with these AmeriCorps folks with maybe 30 minutes of training was phenomenal compared to anything I've seen in the field. So what I have a picture here is essentially what I saw with the AmeriCorps folks, which I thought they did just a phenomenal job. And then I've got a professional group, and this is on a big multifamily project, $10 million project, and this was pervasive throughout the building, just a lot of gaps. You can see there's big gaps, and this was pervasive throughout the whole building with the electrical wiring just stuffed in there. In my mind, that doesn't meet the intent of the energy code. If the energy code said you wanted that R13, R19 in the wall cavity, we aren't getting close. I'd say we're falling way short on actually achieving that U value that's specified in the energy code, which goes to energy prices, energy affordability in the home, but also just comfort of the building. And this comes down to kind of thinking about the subs. It was interesting working with the AmeriCorps folks. It didn't take us all that long. It just seemed like there was a care and a compassion. When I've worked these, when I'm going out on site onto one of these production builds, they're just kind of slapping it in there as fast as they can. And I don't know how to change that, but I know that would make a huge difference. And I don't know if it's necessarily pay or just a cultural shift. It's pay. Yeah. So if we paid more. Yeah. But do you have anything to add with? I really, when I get out into the production world, into the multifamily world, I pretty much see this job over here every time. Anything to add, Brent? Any ideas on how we could improve that?
If, we had this discussion yesterday with our RMJ class. Flex duct gets installed horribly all the time.
Yeah.
Right? Number one, our companies need to train their people that it's not acceptable to do a crappy job, but an inspector needs to tell them that insulation doesn't pass. And, I think if the inspectors were united and really enforced them to do first, number one, insulation installation.
Yep.
Even a number 2.
Even a number 2. I'd take a number 2.
Probably the insulation contractor would probably say, well, I'm going to have to charge you more. And it might be that it's just more cost effective to just net and blow the thing and get a number 1 all the time.
I've seen some really good blown-ins, really great jobs on the blown-in.
If they do a good job with a net and blow, it's wonderful. Mm-hmm. That's my opinion anyway.
Yeah.
It goes around the wires correctly, it goes behind the boxes correctly.
It just, you don't even have to do all the little cutting and puzzling that I did with the AmeriCorps folks. It just kind of works. Anything to add with, you've seen a lot of these.
I actually have a question for anybody here. So like the net and blow seems like a really great approach. One thing we've wondered is, do those settle over time? Yes. Is it significant?
It can if it's not put in dense enough.
Okay.
There's a way to measure it.
And You need to use a
By
density
cutting
meter
it
to
out
measure
and
it.
weighing it.
Okay, so
Nobody does that.
if it's done properly, then it's, okay.
But then that's every cavity.
Random samples.
I had my house, I built my house in 1978. Blown-in cellulose was the big thing at the time. I blew in cellulose, and it was so puffed out on the walls. I had to take a broom and move it up to the top when I put my drywall in it.
Yeah.
And I shot it with my thermal camera. and
Nothing.
It hadn't settled.
Perfect.
It's still there.
That's what we like to hear.
I was shocked. I thought for sure I'd have several inches of cold space up there.
And nothing overly complicated. It was just pretty much kind of the fill with a that vacuum type thing, just net blown in. Nothing special. Because I've seen some.
Back in my time, it was disc queen over the wall and go away cellulose.
Yeah.
This is before they had the netting product. You know?
Yeah. Okay. Well, good to know. Yeah, and this, I mean, one, I wanted to share the what we're seeing in the field with all the homes we get out to is it just seems like insulation, the quality of the exterior insulation, just not there. But also, it was when I see the difference between the two approaches, the high school kids, they cared. The AmeriCorps kids, they cared. And we got really good outcomes. And I don't know if we can somehow shift that culture. I know I'm kind of an optimist guy, hoping that we can do that. But if there's anything we can do as industry professionals, industry experts to kind of shift that culture, let's do it. I'd love to see more of this AmeriCorps grade of install. This is a lesson learned. We learned the hard way on a habitat project. Exterior wall insulation. So we wanted to do exterior insulation because we wanted to go for this Energy Star, actually the Zero Energy Ready certification. And we ran with this exterior wall insulation product. And we also, so essentially adhering to the, if rigid foam is rated for water resistance, which we selected, no other water resistance barrier is required if seams in foam layer are sealed. So we were going to use this tape product per the, I believe it was an Owens Corning product that we installed. We're going to tape it. So we got the insulation up there, or we got the exterior insulation up there, and then this was up in Park City. It snowed. We leave the job for a few weeks, let things dry out. We think that's a good idea. Let's let things dry out. But what happened at the same time is a lot of wind came in and blew some dust and debris onto that exterior insulation, and we couldn't get that tape to stick for the life of us. And so it was a big issue. It was a lesson learned. So the lesson we learned on that project is essentially as soon as you get that exterior insulation up, you need to tape it and seam it, especially if you're going to be using that as your water-resistant barrier. Do you have anything to add there, Brent?
I made this mistake myself, and I've admitted it before, so some of you have heard it. I put polyiso on my house while I was doing some remodeling, and I had some Tyvek tape. And so I taped the seams with Tyvek tape.
Yep.
And there was a few weeks, and the sun had hit it and stuff like that. The tape cracked. I used the wrong tape.
Yep.
So it needs to be a compatible tape.
Yep.
With the product. And like Owens Corning, they have the tape they make for
Yep.
their insulation. So
But
that's important.
But it will not stick if you let that get dirty.
Yeah. You're right.
Learn the hard way with the volunteer labor, and we didn't make that mistake on the next one. We fixed it, but it was a lesson learned, and I don't know. I mean, it seems like kind of a no-brainer, but something I thought I'd share there. Exterior wall insulation in general, we actually got a lot of pushback on exterior insulation. I think exterior insulation is a phenomenal way to insulate a wall, even a roof. Phenomenal way to do it because you don't lose any heat transfer through the framing members. But for whatever reason, we had tremendous amount of pushback, and it was a lot of folks thinking that the facades were going to be an issue, the exterior finishes were going to be an issue, and some folks just said, that's a terrible idea. I don't even want to be part of a project that includes that. We really had a lot of pushback on the projects we've been involved with. Curious is that fairly pervasive with the group? You're getting a lot of pushback? No, you're just hearing people.
Absolutely not. In fact, on commercial, it's just going up like that.
Good.
Because it's the easiest way to put it together. You get rid of at least two trades.
Yep.
So one trade can put it on and do the exterior package totally.
Yep.
Plus they seal everything, and the flashing between the windows are completely taken up.
Yep.
So that there is no problem with any moisture getting in through that building.
Yep.
So it is one of those things, residential, I can't say
Yeah.
Residential's the opposite.
Residential just doesn't have their head pulled out of the
We need to get the window manufacturers to make those windows outset for the foam, so they're not recessed windows. So you still have to put your WRB on first with the windows, flash them all out before you put your foam on.
Yeah.
And then your windows are recessed, and a lot of people don't like that. And you really need to put your furring strips on the outside, you know, so you end up, it's a lot better way, you end up with a rain screen.
Yep.
But a lot of villages aren't willing to spend all the extra steps and money to do
Windows
it.
and doors.
Windows and doors.
I was just on a big builder in Park City, I was talking to him about this today.
Yeah.
He'd like to do it, he said, but we need to get the window manufacturers to get these windows out, for one.
They just have to buck, they just have to buck the window out, it's just about framing.
Yeah, they
Building
gotta
that
know
They
how
can
to
buck it
finish it.
out, but yeah, but it's still, but then, now you got an issue with your window flashings when you buck the window out.
No, you don't. You
It's
really
only
don't.
3/4 of an inch to another 5 with poly ISO, so it's really not that much. So we don't really have an issue with the hardy board application or stucco application, because you're only 3/4 of an inch is very forgiving.
I've seen the hardy sag go on 3/4.
Well, they use the right fasteners.
Well, they're using the nails. You gotta use longer nails.
Probably not the rib mounts, the
Hardy says that they can go up to 1.5 inch minimum. I should say minimum max,
Yeah.
so.
But that nail hanging out there for 1.5 inches through foam can bend over time. You
Yeah.
get little sags in it.
Yeah.
But the big thing is flashing that window cricket. You're forced in, number one, which they should be forced anyway, to use self-adhered flashings on your windows.
Yeah.
But you've got a lot of detailing coming out around that, where you bump things out.
Yep.
Well, it
Yeah.
increases your U factor on the wall if you put exterior insulation.
Mhm.
With certain systems, you can also gain air seal,
Mhm.
air barrier, qualified air barrier,
Mhm.
and then you can eliminate the wrap, so you get a WRB as well. So
Yep.
it's like a 3-in-1 system.
Absolutely. Yeah. Yeah. I think it's a phenomenal system, but it,
Cost effective.
I would still put the wrap behind, because on construction defect cases, I've seen issues with the horizontal tape, because if it comes loose at all, it becomes a hood scoop for water, pulling it right into the building.
That's gotta
That's
tell,
installed.
you gotta teach the guys how to put tape on,
Yeah.
correct? That's the big.
Well, if it's done
It's gotta
perfectly,
be-
you won't have an
it's
issue, but if
gotta be-
anything comes loose, it can scoop the water right in. The same thing with the green plywood buildings, you know, with the tape seams.
Yeah.
That horizontal tape can come loose and scoop the water in. So you're still better off putting a WRB on. It doesn't cost you that much more
yeah.
on the total cost of the house.
Yeah.
Commercial is going that way,
Yeah.
Oh, definitely.
almost 100% right now.
Yeah. Yeah.
Metal studs.
Yeah. Yeah. The metal studs help. But yeah, it's just a lesson learned, and yeah, I love the product. I love that if I were building a home, it would 100% have exterior insulation. I think future iterations of code are likely going to enforce this or try to push this. So, trying to prep the market for maybe not this coming code, but the following code, I could see this being in here. So the more we can get, kind of shift that mindset and figure out, I mean, you're bringing up some valid points on why it's problematic.
You always put the foam on. This is the feedback I'm getting. This is what they're complaining about.
And it's valid. It's valid. It's not all of those concerns are legitimate. I mean, we're building homes for people, and we don't want the callbacks and the complaints. We're trying to, you're trying to balance that whole, what can I build and what do I know is going to work versus some experimenting with stuff. So, yeah, whatever we can do as a group, just trying to promote this and trying to increase the adoption of exterior insulation. I think it's great stuff to be thinking about and having those conversations. All right, then. Yeah.
If you have your little handout, if you go prescriptive code, climate zone 6 and higher, it mandates exterior foam. If you go prescriptive. Now, you don't have to go prescriptive, so you can get out of it, but the code's headed there because in those cold climates, it's really important that you have some on the outside.
Okay, duct sealing. We run into this problem, not so much on the habitat jobs. We have really good contractor on the habitat jobs, Mr. Dan Dearden. It's one of the best, in my opinion. So we don't really have problems with the habitat jobs, but this is something we've just seen kind of fairly pervasive when we actually go do duct blaster tests. Is we're just not seeing a lot of, a lot of it comes back to the air handler. We're seeing just missing the mastics or the tapes at that air handler, and it seems to be a big issue that we especially when we do more. The multifamily buildings seem to really struggle with the duct insulation, especially if they're going for like an Energy Star target or something. Almost always fail, at least the first time. So this is something I'd like to see done a little bit better. Install the air. This is the guidance from the Building America. Install the air handler within the conditioned space of the home. I think in most cases, I think I've seen a lot of that. A lot of folks are putting air handlers in the homes, but we are seeing some outside of the home. Sometimes there's just space constraints or the design of the building just didn't allow it. Well, when we can, let's put them in the home, and we see a lot of that. Seal all seams and holes in the air handler cabinet. I've got an example of where they missed it and an example of where they did a really good job with the tapes. Test the air tightness of the cabinets and ducts with the duct blower test. Verify that the duct system meets code or program air tightness requirements. We've been on some jobs where you turn on the furnace and you can feel the air coming out of it, and you're going, well, yeah, I know it's within the building envelope, and that's great. I don't think the energy modeling programs really pick that up very well. But if it's in the mechanical room and not out in the very far bedroom, you're going to have some comfort issues. And I think that's, I know there's been some comfort issues with the HVAC installation. I'd imagine this is contributing to that. So this is just something that we've seen in the field. Is there anything, you've seen a lot of these. What can you add here?
Yeah, air handler within the home is definitely important, and I would add onto that the ducts inside the conditioned space as well. You're always going to have some amount of leakage and heat loss through the ducts, no matter how well they're installed. But it'll be less of an issue if they're inside the conditioned envelope.
Anything to add with duct sealing, duct insulation?
I beat it up.
You beat it up. Good. That's good. We hit that one. And they're kind of, for the most part, what we see in the field is actually pretty. And I will back up. I did beat up on a couple of topics. We do see a lot of good builders out there, and we see a lot of people. Their intentions are really good, and I think sometimes it's just you get busy building a home. You're doing your job. You're trying to check these boxes, do these tasks, and sometimes things get missed. And I think that's what's contributing to a lot of it. And so essentially, the advice we give is strive to, we've now identified some issues that are being missed, especially with this field study that we talked about earlier. Let's go back and revisit that. Take a step back and go, how can we do this better? There's nothing there that's very complicated, alarming, too expensive to do some of these fixes. Let's pull back, step back. And that essentially ends my presentation. It wasn't, I'm here.
Chris, do you foresee any improvements in the improvement on mechanical system and basically switching to the heat pump split system or VFRs because of so many issues, not only with the ductwork inefficiencies and the future problems, where you have a lot less components and I would say a lot better efficiency?
Yeah, absolutely. So we've tracked distributor sales volumes on heat pumps historically. And there were years that we saw maybe 5 sold in the state of Utah when you go get with all the distributors and go, wow, it's just not a very popular technology. When you look at the amount of heat pumps that are sold these days, it's in the thousands. And that number's really ramping up. So the use of heat pumps, ductless heat pumps, definitely seeing a rapid adoption in those systems. And I'm also liking to see the cold climate specific heat pumps. These are cold climate rated heat pumps. Seeing really great performance on those. So to answer your question, I absolutely do think that. And I think in the next 5 years, you're just going to see more and more adoption. Even some of these production builders are considering the heat pump route. So absolutely.
Especially basically just adding it to new incentives.
Mm-hmm.
Really lowers the basic cost, but gives you long-term gains.
Mm-hmm. Yeah, not only the utility incentives, but that IRA Act actually has some very sizable federal incentive for the heat pump adoption, which I think is really just going to keep accelerating that. So absolutely, yeah. Anything else? Well, cool. It's kind of late in the afternoon. I get it. You guys have had a long day, so I will let you guys out early if you don't have any questions. And I also just thank you all for showing up and supporting energy code adoption and all this. I just think y'all are great. You get together and you meet like this. So not only us as presenters, but to you guys as the group, appreciate your involvement in the industry. So.
Thank you, everybody, for coming. We will be doing another energy code next month, so if you are